Apologies everyone for the inconvenience caused due to the technical issues. We will be continuing the session from where we stopped.
Thank you very much for fixing that. Technical difficulties happen. It's always, it can happen. So we will not have a problem. We may go slightly over because I still want to present the material. So we will continue with that. I'm not sure everyone can see the slides. Can see? Yes. So coming back to the the topic I mentioned with the Lotus Tower, the fluid structure interaction, and with the accelerations being monitored. So with the compressed fluid dynamics, the time and cost are important. Efficiency applicable to wide range of problems, geometric scale, and looking at the compression fluid dynamics have given us many advantages. So I'll skip some of the slides because we lost a bit of time. But the CFD is a key for many things. You can do the compressor fluid dynamics analysis. We leave it to another time. So we do a bit of a model, and then we look at the plan views, the shapes, and this is some work done in CSEC by J. Dillon, some of the compressed fluid dynamics work. So it can really give a lot of work, a lot of information, and the responses and all that. I'll leave it to another day. And looking at some of the work we have done, that is looking at the wind tunnel test and looking at so wind model is done like that. These are compressed fluid dynamics of for a city level as well. So that will give lots of information. Those days we couldn't do that. We had high performance computers that used. Now we can do even in our laptop some of this work because it's a change. The speeds have changed a bit. That's the paper that you'll have access to in the freely downloadable, the paper we have written with one of my former PhD students, Yusuf, and then coming down to the co-authors, and then Mr. Marford as well from here, CSEC, the managing director. So this is where that diagram is. Wind direction, along wind is with the wind, parallel to the wind. Crosswind is across the wind. Wind-related problems. Pedestrian comfort is another very important, really, for pedestrian comfort. It's had to be considered, and this is the work we have done. And at that time, the pedestrian comfort, the works. Can you press the video? That work. So this is where the pedestrian comfort. See near the building, someone is trying to go. That's what happens. I don't know anyone else have experienced this one, and it is a really something happened there. So let's move on. And this is work we did on pedestrian comfort at Melbourne University. Some of the students, we got some students to measure the pedestrian comfort and looking at then we did a CFD models, look at that, skip some of that. So there are some allowable values these days. You can read from some of our papers, the allowable values. And we need to, it was not done those days, but now we are adding the pedestrian comfort levels as well to our studies. Type of damping systems, I'll run through very quickly. The different type of damping systems, the dynamics doesn't work in tall buildings. We need to consider these dampers. Tube mass dampers are the simplest form, where you have like a pendulum. But from more recent work It's now these tuned liquid column dampers. Again, I will leave to another day to talk about detail. We have water tanks anyway in a building. So water tanks work like U-tubes, not the YouTube we are used to, but it's a different type of YouTube, right? Not the YouTube for the that we watch normally, but it's a like YouTube action with the water sloshing from one end to the other end. And when the building moves to one end, water will come to the other end and reduce the dynamics. So water tanks are there anyway. So we use these water tanks. Eureka Tower, Prof. Bill Melbourne, I was also there, but managed to really reduce the dampers by using the water tanks. So these sort of innovative things that happen in the buildings now. As we talked about the other work. So today I won't have time to talk about everything, but just the human response to the build emotions. That is this is where the other criteria. We all know we have been in the planes. You know, when the planes are turbulence is very high turbulence. It's not acceptance criteria. It's the accelerations. And so the comfort criteria, the accelerations, where we measure how we perceive the motion on top of a building. You can really feel it. If you are really dangerous, if you feel the motions, it can happen a little bit, but not too much. We don't like to sometimes rough sea travel because the boat is rocking too much and we feel uncomfortable. That's the kind of action in the building. We don't carefully design the building. You will have the motion, the perception of motion is we need to satisfy. So this is another governing criteria. Two governing criteria in tall buildings. Most important is one is wind drift design, other one is its accelerations. I will not go into detail. Some of the work I did with Prof. Bill Melbourne at that time being used in a number of places. The acceleration on the y-axis, frequency on the x-axis. So I'll leave it to another day. So these sort of perception of motion, we can look at now ISO 10137, peak accelerations, allowable values versus the frequency. So some of that will be in the some of the papers. Wind tunnel testing very quickly. We need to do the wind tunnel test really to get it right. We rotate the wind tunnel, look at the wind speeds from different sides, and then calculate the loads. That's the Burj Khalifa on the right-hand side. Why we don't need a full city? Because it's so tall, we don't need to model the full city. Lotus Tower is the same. We didn't put any other buildings, just at that building because it's so tall compared to the other buildings. Usually, you have to have all the other buildings to look at what's called the interference as well. And so a type of wind tunnel test, I'll skip some of that work. That's for the work for the Jeddah Tower. And the type of wind tunnel test being done, did for the Lotus Tower is high frequency force balance test, integration test, aeroelastic modeling. I'll do another webinar, maybe another talk on just some of these topics. Today, I'm really looking at an overview of the state of the art at the moment. So I'll skip some of that. And there are papers available. It's not our paper, but very good paper. If you can see here, you can download and look at this. The paper on the wind loading, wind tunnel testing side, and it's really, you can Google and look at some of these papers as well. So wind tunnel tests are a key for a tall building. Every tall building had to go through this. You do about 400 scale, 1 to 400. So 400 meter tall building will be about 1 meter. But when it becomes taller, I think the Merdeka was about 800, or the Burj Khalifa 800, 1 to 800. Or just too tall. 824 meter building will be, if you try to do 400 meters, you need 2 meters. So it was done 1 to 800 scale. So actually good to have 1 to 400, but very tall buildings, we have about 1 to 800. And then you try to put all the other buildings about 500 meter radius all round. And then you have that all the buildings, and so you can look at the interference from the other buildings. Sometimes the governing criteria is the interference coming from other buildings. That's why we can't just use the codes and to have that. And the AI in wind engineering, I'll run through very quickly. I think we still have, I think, some technical difficulties, but the AI in wind engineering with the wind tunnel test, we have the AI is a very important one. Now AI is coming to anything, like everything. And the recent forum we did here in the CTBH forum, we talked about AI in design and construction. But the wind tunnel test, I'll leave it to another day, talk about how AI can be incorporated into the wind tunnel testing and looking at more better predictions. That's coming in a big way at the state of the art. You will see a bit more AI coming into our wind designs in the future for high-rise structures. I'll leave that to another day. So these are the wind tunnel results. Finishing off with the telecom headquarters. So it's a case study looking at the building, looking at we draw this through the wind tunnel test, what's called ellipses, and we can do the type of structural design, and we can look at the loads, tension on the y-axis, on one side, compression on the other side, and we can look at the design side. After that, the Lotus Tower went through some of that work, pressure fluid dynamics, see the model with the roughness elements, and I'll skip some of that theory there, but then we did the mast as well, similar way, and the wind monitoring system to end where the CSEC wind there with the engineer Chamil and engineer Dilas guidance. Wind monitor, wind monitor system. Wind monitor is a key. It's probably, I don't know many buildings that wind monitoring is done. So this Lotus Tower wind monitoring system with at this particular level, the calibrations at the 266 meter level, there are an anemometer as well as accelerometer. So we can do these comparisons through this wind monitoring system. That is one of the first to be done like that at very large heights. And the 266 meters and the anemometer on the left-hand side, and the measuring equipment. Yes, moving. That's the anemometer a bit right at the top. We'll leave that to another day to talk about a bit more detail. That's very efficient system with the live updates. But I think anyone can have that updates. I think you can see the wind speeds and looking at that the website. So live update is given. You can look at the wind speeds from your own telephone or phone, but with looking at that. So this very, I have to apologize for the technical difficulties, but it's a very quick update on where the state of the art is, and we will look at a bit more of bit more detail in the other webinars and maybe a longer forum, but today is very much an overview of where the world is moving with the wind designs, the wind tunnel testing side. Compressor fluid dynamics is another one which is moving, but then I have a few PhD students on that too, PhD students, and we are really on the building the high-rise side. And the third one is the monitoring we talked about, and the incorporation of AI. I'll do that another day. Talk about AI in the how in the wind design, and also I admire Dr. Amit Mohanty's work in a number of other developments in that side, AI and the wind designs and all that. So we will hear some of those objects. I'm happy to present another time with more detail. And today's, as I said, overview. And thank you very much for listening to me today.
Thank you everyone for joining today's webinar. And we would like to once again apologize for the inconvenience caused by the technical issues we had. And The Google form link is now open and the certificates will be provided to only those who fill out the form. And the form will only be open for a few more minutes. Make sure your name is provided correctly as this will not be changed later. If you fill the form correctly, you will get your response email to your automatically indicating that it's complete and that you will get your certificate. If you don't get the email, chances are that you did not submit the form correctly. So if on the off chance you face some issues, take a screenshot and inform us after the session has ended. Please WhatsApp message us because we won't be able to answer calls at that time. And meanwhile, we would now like to open the floor for any questions. If you have any questions that you would like to direct to the speaker, you may now put it in the chat. So we'll be answering the questions for you.
There were some comments right through, so I'm not sure whether you captured them, but some questions right through there before. But I just saw that there were some questions, but I think we can, I don't think we'll have time to answer all the questions, but maybe I think we might put it again, no? There were some number of questions.
You had put any questions on the previous live stream chat, please put it in this live stream chat as well, as we do not have the comments or the questions with us since the stream ended, unfortunately. So if you can, please do send us the questions back again.
Right. So the question is on the outriggers, right? Outrigger and the belt truss system. So the outrigger system is joining the core to the outside column to really work together to release the bit of a moment from the core. Now, you can have a 1 mega column you saw with the Merdeka-like system where couple of mega columns. But then to really engage other columns in other systems, you can really use the belt truss to really engage more columns. Because outrigger is connected to only one column or 1 or 2 columns. But to engage all the other columns in that strip, we can use the belt truss. So belt truss will really help to so that all work together, some of the other columns, not just one column that outrigger is connected. So, but it's you saw in the, I think the Eureka one also we didn't use belt truss just because there was a column and mega column and then joining the core to that mega column. But so in Merdeka very similar. But some of the other systems where the outriggers, some belt trusses have been used. Number of examples where I didn't go into detail today on the structural concepts. Maybe we'll leave it to another day to talk about structure. Good question. That's been there are in been popular for many. I remember belt truss was sort of considered initial workshops in Merdeka Tower, but ended up not having those belt trusses. But some of the belt trusses, yeah, there were some belt trusses. Yes. That's correct. Yeah, that is a belt. They are the belt trusses. Correct. So very tall structures, belt truss really be very very useful. I think we'll leave like that for today. I think maybe people can send emails.
If you have any more questions, please do contact us from the WhatsApp group or the WhatsApp channel, or you may also email us your questions through contact@sdi.lk, and we will direct the questions to the speaker and we will get back to you with the answers for them. So with that, we would now like to conclude this session. And if you, before concluding, I would like to apologize once again for the inconvenience caused. If you are interested in our future webinars, upcoming courses or publications, then please keep an eye on our social media platforms, the WhatsApp group and channel. And thank you all once again, and we will see you at our next webinar. Thank you. Thank you, Professor, also for joining us and enlightening us with your valuable insights.
Thank you.